everyone. I think we are live and welcome to Hedera's Hello Future Ascension's second workshop. And we're thrilled to have you here as we dive into another exciting session designed to help you level up your skills and understanding of what's possible with Hedera. Yep. The workshop title and theme for tonight, for today, wherever you are, is Trustless Agentic Systems and how ERC-8004 and x402 shape the future. Our focus today is on how developers can leverage the latest agentic standards, which is what I mentioned, ERC 8004 and X402, to build the next generation of intelligent decentralized systems on Hedera. Okay, so I'm just going to show and present my screen here. Right. Okay, thanks for that. Okay, so why this topic matters? AI and autonomous agents are some of the hottest topics in tech right now. We're seeing a massive shift towards systems that can act, learn, and make decisions, not just respond. And tonight or today, meet your speaker. Today's workshop will be led by Jake Hall, the Developer Relations Engineer at Hedera. Jake is passionate about everything blockchain and AI, and he's here to help you understand how to bridge these two worlds. So please feel free to reach out to him anytime on Discord server. Just tag him in the Mentors Assistant channel under the Ascension's Hackathon server. Okay, so about the questions, if you ask me, we might not be able to answer the questions live today, as this session could also run a bit long, but don't worry. On our screen, I'm going to share you this QR code. Okay, this QR code is our AMA Session 1 form. So if you have any question regarding tonight or today's session, please put it here. And definitely on November 7, which is on Friday at 10 a.m. Eastern Time, once again, Eastern Time, please join our live AMA sessions, and you will definitely have a one-on-one session with our mentors. So once you put up your questions there, please feel free to join our AMA on Friday, November 7. And apart from that, not just that you're going to have a free mentorship, but then you will also earn some rewards. So we have NFTs to win. We also have $40 per team. And we also have a bonus raffle. So that is a really, really good win-win for you guys. So please join our AMAs, okay? Now we're going to start our workshop, and let's listen to Jake.
Agent stuff. Firstly, I do want to start off. I'm sorry I'm not able to do this live. It was quite late for me, so I've just pre-recorded this. But we're going to take a real deep dive. We're going to get really technical, really into it, to be fair, on how you can build AI agents which leverage all of the latest innovations in the AI agent and Web3 space. So in particular, we're going to be looking at how you can create AI agents that can earn revenue and can pay each other. AI agents which have their own identity on a decentralized ledger, blockchain, and also the latest technologies for how you can communicate with AI agents. So let's get into sort of the three pillars that we're covering. And like I mentioned, the first one is this identity layer. It's the ability to actually identify AI agents, know where they're located, but also know whether you can trust them or not. As we sort of go into this agentic web where we're interacting with AI agents more and more often, we are obviously using ChatGPT basically every single day. That's an AI agent inside of our browser. Now these companies are also releasing agentic browsers, and very soon, definitely within the next few years, we'll see companies expose AI agents, and we're going to have AI agents communicating with other AI agents. We need to know exactly where they are, where they're located. Are they on a web server? Are they on this or that? And we also need to know, how can we trust them? And obviously blockchain gives a really nice way of doing that in a decentralized way. We're going to get into exactly how blockchain enables that. The other thing that you need is you need that communication layer. You need to be able to speak to an AI agent programmatically, either as a human or an AI agent speaking to an AI agent. So that's using sort of your communication rails, like a HTTPS requests, for example, post requests, whatever, similar when it comes to AI agents. And finally, you need to have a payment layer. You need to actually be able to pay the AI agent, or not always, of course, but there will be times where an AI agent wants to do something for you, and it's going to require a fee. So you need to be able to pay them. Again, blockchain gives a really, really good solution to that. So for each of those layers, we're going to be covering the technology which is emerging as the most prominent at the moment. On the identity layer, we've got this ERC-8004. On the communication layer, Google's A2A is now an open source protocol. I think it's actually owned by the Linux Foundation now, but agent to agent is sort of the communication protocol for agents. And then finally for payments, we're going to be looking at x402. And I'm going to get straight into the code because my idea is that actually by seeing it in practice, we'll be able to, by seeing it in practice, you'll be able to sort of better understand the actual theory behind it. If you do want to take part and you do want to have a look at this repo, which we're going to look into, have a look at that QR code. So I'll leave this on the screen for a while. That QR code will take you to the GitHub repository with all of the folders and all of the source code that we're going to be working on today. Okay, so let's now go over to the code. And the first thing that we're going to be looking at is more just on that agentic, we're going to be looking more on that agentic communication side. So we're going to be quickly skimming over A2A. One of the repos, one of the folders that you'll see over here, right at the root, is this A2A agent. So just to sort of really have a quick look at what an actual agent-to-agent agent looks like. This is basically it. You've got a server where the agent sits on, and every single AI agent, according to the A2A spec, has an agent card. So this agent card, you can find all of these. All of these types and all of these APIs from the A2A-JS/SDK repository. There's also one for Python as well. But every single agent has this agent card, which basically tells you what the agent does, where it sits, what its skills are, its capabilities. Can it do streaming? Streaming is that sort of that word by word messaging that you get when you're talking to ChatGPT, for example. It doesn't come out all in one block, it's streamed out. So this tells you whether the agent does streaming, default input modes and output modes, and various sort of various data points which would allow a client to understand actually how do I deal with this particular AI agent. So there's you sort of implement this class and then you host it on in this case we're hosting it on an Express server. I don't want to go into this into too much detail because we'll cover it actually within the context of the payment stuff. But that's basically the most quick, easy way you can spin up an agent-to-agent compatible server. And at the moment, all that happens is whenever a request gets sent to the AI agent via, that's awkward. That should be hello world. Whenever a request gets sent, then all that's happening is it's just responding with this message. So it's very straightforward in this case, but typically, and what we'll see in the next example, is we'll see it being used with an actual AI agent. For the client, the thing which is connecting and sending the request to the agent, again, you've got sort of helper functions and types which come out of that A2A-JS SDK. And all you need to do is you need to create your client, which connects towards the agent card. You pass in the agent card over there and you just send it a message. And again, with an AI agent, that would be the sort of prompt, essentially. But that's just a really quick coverage on the A2A. Where I want to show it in practice is actually I want to show it in practice with regards to the x402 protocol. So let's now take a bit of a step away from agents. We'll just focus on x402 and actually what it is. X402 is a web-based protocol which makes it very easy to accept crypto payments like stable coins. It makes it very easy to accept crypto payments on existing web servers. So say you've got a web server with business logic, and I want to put myself on the screen again because I think it's a bit more engaging. Let me let me wiggle stuff around. Give me a second. There we go. Sorry about that. So what x402 does, I just covered that. What x402 does, it gives you a way to take payments for an API that you may have, business logic, your IP, your intellectual property, something which is valuable, and it will allow you to wrap it with a payment sort of middleware layer. Basically meaning whenever someone wants to try and access your resource, your business logic, when everybody wants to try and access it, they need to pay you an amount in stablecoin. So you can think of it as really great for enabling things like micropayments. And a good example as to where this is being used in the real world is with Cloudflare. Cloudflare are actually one of the main contributors to X402. They're part of the X402 Foundation. And Cloudflare, they have, they're talking about doing things like pay-per-crawl. So actually going to, let's say, the Financial Times or a very high quality news platform and actually going, okay, either you can buy a subscription or you can actually pay per use, pay per request using the X402 protocol. We'll see how easy it is just now. And it'll be essentially another way to generate revenue. It's particularly relevant for AI agents as well, right? Where you can actually have an AI agent crawl these particular data sources, use it for its own training, but pay a fee. So let's take a look at actually what that looks like. Again, I've given sort of the theory, but let's see it in practice. So for a developer who wants to actually set this up, it's really easy. Now it doesn't even look, it looks a bit uglier over here. But if we, that's because I've got some agentic A2A code. But let me show you what it's like sort of in another repo. So I'm going to go to x402-Hedera. So if I just go over here where it's a bit tidier, and we go to examples types. This is our Hedera's implementation of X402. You can find it at Hedera-dev, X402 Hedera. And if you go to the servers, and we'll just go to the Express server, you'll see that essentially I've got, you just take your existing Express server with all of these endpoints, a get endpoint, various get endpoints. This can be post endpoints as well. And all you need to add is this middleware. So you go to the X402 Express library, import that middleware, and any one of the endpoints that you have that you want to start receiving pay-per-use payments for, you just specify inside of this middleware. So for example, over here, the get endpoint, the get Hedera-USDC is going to cost 0.1%. And with these 15 lines of code, we've now actually gated these two endpoints. And it's really that easy. It's very, very developer friendly, which is why it's sort of been picking up in adoption. Now, what we've done is we've set up our A2A server. As you can see over here, we've got our agent to agent server. This code looks quite similar to the code I was sharing earlier. And lost my train of thought. Sorry about that. So we've got the agent to agent logic over here, and then we're setting it up so it's sort of living on this Express server at the A2A endpoint. This is a post endpoint, and we're basically saying, okay, I'm going to use that payment middleware wrapper to wrap the agent A2A server. And I'm going to say every time someone interacts with that server, it's going to cost them 0.1%. So just to sort of recap that, we're creating an agent-to-agent protocol server over here. We've got our agent card. We are creating our agent executor, and we're configuring it using all of the utility, sort of the helpers that A2A provide. We're then using this app builder.setup routes method to say, okay, we're going to register our AI agent at this A2A endpoint. I mean, this could be anything though. This could be test agent, for example. It can be whatever you want. And then just before it, we're doing this middleware, taking using the middleware helper function from X402 and saying, okay, anytime somebody wants to post to this A2A endpoint, they're going to need to pay 0.1%. And with that, we can now go over to a client and actually start interacting with it. So before we do that, I want to give a bit more context around the X402 architecture. So there's another interesting player in the X402 architecture, which is this facilitator. And essentially the facilitator helps separate the concerns of the actual blockchain logic and the business logic. So as a engineer, as a developer who's got their own product, you've got your own product, you want to start monetizing it, you don't actually need to really worry about blockchain too much. The only thing that you as a developer need to specify is what the facilitator URL is and where you want the user's payment to go to, the pay to address. And with that, you don't actually need to do any blockchain transactions, because essentially what happens is all of that gets outsourced to the facilitator. So the facilitator, in our case, we're going to run it locally, but the facilitator is responsible, one, for verifying the transaction that is generated from the client is actually legitimate. And then once that's done, it will settle the transaction. So it'll actually execute it. So we've got this facilitator which is responsible for that. But I just wanted to sort of mention that facilitator is a very important part of that sort of X402 architecture. It separates the actual blockchain execution on a different server, and many people can connect to that same facilitator. Many people can connect to the same one. On the client side, we'll just do a quick sort of code. This is in for those of you who want to know where the files are for this, it's all inside of the X402 folder. And then if you go to examples TypeScript, you can see we have the Express server, the facilitator, and the Axios client. And what this Axios client does is it just simulates the actual querying of the endpoint. So in this case, we're going to be querying our server, which contains the AI agent. So we're querying the server over here. We're using this with payment interceptor helper function from X402, and we're creating our signer. Our signer is obviously a Hedera account. We've got the RPC request. So this is actually just the request body that gets sent to the server, because agent to agent uses RPC protocol. It doesn't just use a typical REST API. It uses RPC and JSON, like a JSON RPC request. And then we're just posting that JSON RPC request to our endpoint. And then we can see over here, we're just sort of passing the logic. Let's see it in action. Let's actually take a look at what this sort of all looks like pieced together. So in each of these endpoints, each of these servers I'm sort of running, so I'll go over it again. But I have got my facilitator, so I'm going to run pnpm dev to spin up my facilitator. And obviously I've got some environment variables configured. If you go through the repo, you'll be able to see that yourself. I'm going to spin up the server, the server which has the agent-to-agent endpoint. And just quickly, what actually is this agent doing? So if we take a look at our agent, we can see that, like in the first example, we've got this agent executor. We've got this execute function. But this time we're actually doing something a bit more meaningful than just responding with some hard-coded text. We're actually invoking an AI agent that we have. So this AI agent, very straightforward. I mean, it's technically not even an agent, it's just an LLM. It randomly picks a stock from the NASDAQ exchange and then gives a summary on the company. So it's very straightforward. We are taking the user's request, the text that the user sends, the client sends, and then we are generating the response. And that's what then we're responding back. So this is what's going to cost 1/10%. And then on the client side, what we're actually sending is we're sending this question or this prompt, tell me about stock. So if we've got the facilitator running, we've got the server running, now I just need to do a test of running this script at pnpm dev as well. And we'll see that we get a response from the agent saying, agent message, sure, let me randomly select a stock from the NASDAQ exchange, DocuSign, giving me some information about that. And we can see that actually it's also, the transaction's also been executed successfully. So if we go over to our, here it is. If we go over to our hash scan, we can see this transaction ID, and we've sent 1/10 of a cent to the, there we go, yeah, 1/10 of a cent USDC to this recipient account, which was specified as the Pay2 account. So it's pretty cool. It's pretty cool. Basically what we've done is, yeah, we've set up an AI agent which is able to receive a payment using the A2A protocol, and a client, which also could be an AI agent, is able to pay it. And this is really powerful. But you might be thinking, what about the trust? Which is sort of what we were alluding to earlier. If these agents are autonomous, obviously this is a very controlled environment where I've got the agent A2A server. I know that it's I know that it's safe to use because I built it. I'm also the client. But what if we're in this futuristic world, which probably isn't too far away, where AI agents have got a lot of freedom, a lot of free reign, a lot of control. They can discover other AI agents. They've got the ability to connect. I've got an AI agent which is working on my behalf, and it knows everything that I sort of need to do day to day. Maybe it's a business agent. It knows exactly when my meetings are. It knows exactly who I need to speak to. Maybe it starts doing some research on this client. Maybe it goes to this data broker, where my AI agent goes to this data broker agent, which sells data about other people, just like sort of what Facebook and that do. I'm totally spitballing here as well. This is not even thought about this use case before. But my AI agent needs to be able to know that if it pays this AI agent to tell me about the business opportunity or this talk which I'm going to, my AI agent needs to know that it can trust, and that actually this AI agent, which it's dealing with, is going to provide value. And that's where ERC-8004 comes in. So ERC-8004, at its sort of most fundamental thing, it's just a set of smart contracts. Now I'm gonna quickly find this. I'm gonna dig around quickly for this article. Let me find a very good article which I should have pulled up before. Hopefully I can find, there we go, I've got it. So here's a really, brilliant. Okay, there we go. So this is a really great article which sort of gives a high-level overview as to ERC-8004, what it actually is. And as it says over here, it's a standard that defines a framework for autonomous agents to identify each other, to find, evaluate, and interact with each other trustlessly. So it's got these three registries, this identity registry, this reputation registry, and this validation registry. And each of these is the composable primitives which a developer is able to then build on top of to actually create applications that enable agents to trust each other. So the identity, as I sort of briefly mentioned earlier, the identity gives the agent an ID. It's actually an NFT. And with it, it's got this schema which can point towards maybe your agent-to-agent card, if you've got an agent-to-agent agent. And then it also has this reputation registry. So essentially, we're going to get into this. I'm going to do a quick demo of it, but you can then map reputation onto your AI agent, onto the identity, so that when I go to use this data broker agent, for example, I can actually look, my agent can actually look at all of the reputation, all of the feedback that's been given to then decide whether it wants to trust it. And then finally, you've got this validation registry. Now, this isn't always required, but this is essentially, I like to think of it a bit like the reputation for the reputation. It's just making sure that this reputation, which is given to the particular AI agent, isn't totally botched. It's not a botched job. It's not fake. The validation actually goes, okay, does the reputation feedback actually carry any weight? I've not really looked into validation too much, but it's definitely important because it's very easy to just totally falsify the reputation registry. But as it says over here, the sort of entire the entire framework is very unopinionated. It just gives you the primitives to build on top. But let's have a quick look at actually what it looks like. Again, we've got snippets inside of this code repo. So if you go over to this time, if you go to the the ERC-8004 JS folder, and you go in here, you can see that we've got this Hedera test script, test Hedera. Obviously, I've installed everything, I've built everything, but essentially this test Hedera script, it goes through those steps of registering an agent and then giving it feedback. So we can sort of see it bit by bit. We'll also run the scripts. Let's maybe run the script first, and then we can go through it sort of one by one. So I'm inside of that repo and I'm just running pnpm test. That's triggering this script to run. So we've got an agent owner, which is going to be registering the AI agent, which is actually the AI agent that we just created. So we can see, for example, over here, we're just setting up our EVM addresses. We are registering our ERC-8004 client. We're specifying the registries. Hedera, we already have our own deployed registries. You can find this on the, ERC-8004 smart contracts on GitHub. But we're using this ERC-8004 client. This comes with a lot of methods that we can use to interact with the registries. We are first of all registering the agent. So what this is doing, we can have a look at the transaction hash. What this is doing is it's going to be invoking it's going to be calling the identity registry. Oh, surprise. Let's put this more. Yeah. So this is going to be invoking our identity registry over here. And it's just essentially minting an NFT. That's all it is. And the owner is the one who actually registers it. So the account which I've set up, this client, where it has the sign up, that's going to be the owner. Now, we can then get the agent ID in that response. And then what we can do is we can actually set the metadata of our AI agent. So after creating it, we then get this agent ID. And with that, we can generate the metadata over here, which is it's a standardized schema. And you'll see that we pass in the endpoints. So we've got the name, we've got the description, we've got the endpoints. It's an A2A endpoint, and this just points towards our agent, which we've set up. So if we go over to our server, you can see that we have this agent card, which is what we deployed earlier on. That's what lives inside of the x402 Hedera repo. And it's specifying all of the trust mechanisms. In our case, it's just reputation, but you can also have further trust mechanisms which relate to the validation part. And importantly, inside of this registrations array, we then point back to the agent ID on our identity registry. This is really important because this makes sure that the agent that's registered on the smart contract is actually the right agent. It's not like someone's just randomly registered an agent which doesn't belong to them. This actually proves that, okay, this agent does belong to me. Now, that's then essentially added to the metadata of this agent ID. That metadata, it can be hosted on a web server, it can be hosted on IPFS, you can really do whatever you want there. There's sort of no must-dos, but we're setting the metadata. And then, once we set the metadata, we're then testing around the feedback. So I'm going to sort of explain the feedback now, going over to our agent example, which we had over here, where essentially what happens with the feedback is when an AI agent or when a client interacts with a server. So in our case, it was over here, we had this script which was acting as the client, and it was interacting with this agent-to-agent server. When that initially happens, what should take place is the AI agent, which is on the server, the AI agent on the server should authorize the feedback to be given. So they're going to call this create feedback auth method, which essentially goes, I'm going to let you, the client who's just spoken to me, I'm going to give you the ability to leave feedback on my reputation registry. And you can see that it specifies the feedback giver. So it's not just anyone who can give the feedback, it's only the person who's sent the request. So user will send the client will send the request saying, I want to pay 5 USDC to get your endpoint, to get your business logic. And then the server AI agent will go, okay, I'm going to now give you authorization to actually leave feedback on my registry. And then with that, they'll sign it, just again to make sure that it's actually been authorized by them. And then the feedback client, the client which is going to give feedback, is able to actually give feedback using that feedback signed authorization token, essentially. So that feedback is a score of 0 to 100, and you can also give a feedback URI. So this is quite interesting, this feedback URI. It basically allows you to enrich the data that gets given to the AI agent on their feedback registry. And the ERC-8004 docs, over here it talks about using IPFS. So here it says you can use, we've got this feedback, so give feedback, which accepts a file URI pointing to an off-chain JSON containing additional information and its hash to guarantee integrity. Now, obviously, if you're just taking feedback and you're just chucking it, and that feedback lives on a web server which can be changed, you're going to want to obviously hash it so that on the smart contract it has the hash, so you can see if someone ever changes it, well, actually that's been changed because the smart contract has the hash. The hash is now different. Someone's obviously altered and tampered with it. But the docs over here, the EIP, also mentions that you can use IPFS, and in which case IPFS is deterministic. You can't change it, and in that case, you don't need to use the hash. Now, IPFS still has its own problems because you need to pin it on IPFS, and there's a chance that it gets lost. So actually, with this example, there's an interesting implementation which uses HCS, the Hedera consensus service, which is on-chain and allows you to put the reputation on-chain as well. So I thought that's a quite nice to have, and definitely a great use case for the Hedera consensus service, where you can have this on-chain immutable thing that will never get lost, and you can use that for the feedback. But that's essentially it. And then you can obviously read the feedback. The feedback will get indexed, so you can sort of look at it and then use it as part of your discovery process. But that's sort of a quick summary in terms of how the ERC-8004 ties in, and I think you'll be able to understand why exactly is it important. Well, yeah, if you're going to be having AI agents that are AI agents which are interacting with each other, they need to have a safe way to trust each other, essentially. But that's it from me. I've gone on for a bit. I'm going to go back over here. So I think final sort of call to action, join the Discord. Really, yeah, we're going to be really active in sort of helping out the Discord. Would love to see how you are using agent-to-agent x402, ERC-8004 to build some of the most disruptive sort of applications that are going to be around. It's really quite an exciting time, and all of these pieces are coming together and merging very well. So without further ado, have a great day, everyone. Take care.
Wonderful. That is a very wonderful sharing, Jake. So this is so insightful workshop, right? And I can see that there are a lot of you who sounds excited and amazed of what Jake has shared. And indeed, yes, he made it easy for participants in the Ascension Hackathon. So please make use of what you have learned today or tonight. And let's go to the hackathon. All right, so I'm going to share some of a wonderful details about the hackathon once again, so that to make you excited about our first AMA session. I will show you our mentors.
Yes. Thank you, Charlene. Also, thank you, Jake, for the really good explanation about ERC 8004 and x402. So let's now proceed with the key dates. Regarding key dates, this is like a reminder. We have 3 AMAs, the 7th of November, 13th of November, and 18th of November, 10 a.m. Standard Time. Now, we are going to explore how the AMA platform works. So once you enter to the link that Charlene provided to all of you, it's really easy. You put your profile, your nickname, and you can enter. Once you enter, I don't know, this is the kind of things that you can make. Like you can jump like doing a space. You can use one for thumbs up, 2 for like clap hands, 3 for hearts, 4 for like loading. Now here, in case that you haven't registered, you can click here the F, and it opens the Hello Future Hackathon Dev when you can .dev a landing page where you can see like the old Hello Future Trilogy, and also you can register. Now let's enter to the place. So in this stage is going to appear all the speakers, all the mentors, when you can make some like live questions. How? You click here in the bottom left on chatting, and here on chatting you can ask whatever question you want right here, and that questions are going to be answered by the mentors that are going to be the speakers. Now this is a cool nice to do for all the hackathon participants. We have 6 different tracks on these hackathons that are the following, the one that I'm showing you on the top. So let's start one by one. Let's remember that on AI and agents, we are going to have the following mentors. We are going to have, wait a moment. We are going to have Michael, he's a DA of Hashgraph. Also Jake, DevRel of Hashgraph. Ijas, he's a really good DA, and Luke Forrest at DevRel Engineering. So here, how this works. If I enter here to this room, I will have like a private conversation with all these mentors. Yeah. So this is a good place for asking questions related to that track. Also, we are going to have for DeFi and tokenization, like the structure is the same. The only thing that is going to change is there are the mentors. We are going to have Kieran, a DA, Nadine, a DA of Hashgraph, Michael Garber also, and Luke Forrest. So that's how this works. Also for sustainability, you can enter here after this like main session. You can have this private conversation with them. And here you have Ed Marquez, head of DevRel, Giuseppe, he's a DA focused on sustainability, and Luke Forrest. Also, you can check on IoT and DePIN. You have a Michael Garber and Luke Forrest. Open tracks, you have Jake, Ed, Luke, and Kieran. And last but not least, Legacy Builders, that is the track built for people that have already participated in a past hackathon with a project. You can keep your same project and keep building on this hackathon and improving it. On the Legacy Builders track, we have included also this open track for some people that want to apply in a track that is not included in the last we mentioned. So that is all. Something additional that let's imagine that I'm here on this Edge and IoT room, and I want to say, I don't know, I'm saying to Luke, I want a private conversation about my project, to have a more private conversation, because here, if I don't know, let's imagine that there is other participant, they are going to hear your questions, and let's imagine that this is something more private. So I can come here to this coffee room, and I can enter to this private area and have a more private conversation with a mentor or with a teammate or with other hackathon participants. And yes, that's all regarding the AMA. So see you next 7th of November at 10 a.m. East time.
Wonderful. Thanks for that sharing, Louis. So hopefully all of you had an insight of how our AMA looks like. And definitely we have this design with you in mind, so that it's not just about hackathon, it's not just about coding, but we wanted to make sure that the place where you can all go talk to each other, even with your co-participants or mentors, is something that's more gamified and an enjoyable place for you to talk. So once again, if you have any questions, and I understand that there were people who were asking for the repo link, please put your questions here. Please scan this QR code right here in front of you, and then we're going to get back to you with the answers. We'll definitely get you the repo link, but please give us your email address so that we can get back to you and give you the link. All right? Okay, I think that's all, and we had learned quite a lot of things in this session. Thank you, Jake, for hosting it. I understand that a lot of you has a lot of questions and quite excited. So see you once again on November 7th, AMA. All right, and have a great night, have a great morning or afternoon to everyone.